equation is stable or not, you can solve the eigenvalues and check their real parts of eigenvalue. If the real parts of eigenvalue is less than 0, and then they will be stable. Alright, so there's a disadvantages when you convert from second order to first order, because when you convert it, then you really lose this kind of nice properties. But when you convert it, then it becomes first order equations, because the first order equation becomes state space equations. The state space equation, then you can design controller design controller based on the first order equation of motions. All right, I think I have done enough to explain to you the stability issues for the first order equations. Okay. I think that's the conversion. That's about the conversion of the continuous time from second order equation to first order equations. And normally, the second order equation, this is coming from physical law, right? I think this is come from physical law. Alright? And when it converted, it becomes this, and that is AC. By the way, this conversion is only one-way conversion. That is not unique conversion. You can convert from second order to first order many different ways. There's several different ways to convert it, and this is the easiest way, also the most popular way to convert it from the second order to the first order. Okay. So that is the from second order to first order. Now let us move to the discrete time model. The discrete time model is really a different ball game. You can listen very carefully, and they have many different constraints and different conditions you have to satisfy so that you can use discrete time model. However, the discrete model is the only one model that you can use your computer, because your computer is discrete time in nature. So you can use your computer to design a controller. Unless you say, okay, my sampling time or sampling interval is very, very small. You can, I consider this is continuous. That's not quite true also in some sense. Now I always like to use a very simple model with a single state. This is not even a mechanical system. It's a single state, like heat transfer system like this, all right? The xt equal to acxt plus bcu. If you want to solve these equations, this equation can be easy to solve, then xt equal to exponential act x0 plus integral from 0 to t, then e exponential ac parenthesis t minus tau parenthesis bc u tau d tau. Now, if u tau is known, if you know u tau, then you can integrate to get your x, to get your time history of the state x. So this is only single state. It's easier to discuss single state, so you still remember how to solve these equations. This is very, very important assumption in discrete time. Let's assume you say state xt at time t equal to t. For t, ut equal to u0, for all t larger than equal to 0 and smaller than t. Okay. In other words, I assume if my t satisfies these conditions, that means if t is inside the period of 0 to t, then my u is a constant. That's the same, the same as your music. You listen to music, your CD, right? And you know that all the music now is digital music. So, if you listen carefully, if somebody got a nice ear, you will find out that in that period of time, they are constant what? Constant voice, right? Constant. It's a constant tune. Like me, my ear is not that sensitive. I don't feel. Some real good musicians, they like rather to listen to analog, those discs, rather than digital, because they know the digital is not real music. That's what they say. But you have no choice. As soon as you got the digital sense, then you have to have this. Like a picture, the same thing. The picture depends on how much pixel you got, right? You got more pixel, your picture is not better. If you have less pictures, you not be like a spot. You very careful, right? All different spots. Agree? Yeah, right. So the same thing here. If I assume ut equal to u0, when t larger equal to 0 and smaller than t, then if my xt, I can integrate this xt become this. EACT x0, this t is the same now t, and plus from integral from 0 to cap t, then EACT minus tau d tau bc. Now u0 I can move to outside the integral. Right? My u0 I move outside the integral because from 0 to t, my u is a constant. That's u0. Of course, I assume bc is a constant, ac is constant. Then my integration is become this: EACT u0 plus ac minus inverse parenthesis EACT minus 1 b0 u0, right? In that period of time. Is that true? You gotta look at this. You gotta look at from here integral from this step to that step. Assume this is true, then I got this. Well, look at that carefully. You got to agree with me before I go on. If you don't agree with me when I go on, you will get lost. And this is true. Yeah, be careful, right? Before you speak. Be careful with that. Okay? Any problem? Any questions? Am I doing right? Wrong, right? Agree? Easy. That's an easy problem. Alright, that's one step. So I have a cap t. Now the second step, I say t equal to 2t. And my u, what is my u? My ut equal to ut at that t. So when t from cap t to 2 cap t, then my ut is equal to u cap t. Okay? So that's my second period. This is just like my sampling period. At my each sampling period, I assume the import is constant. Oh, well, that's because your computer can only handle this. Okay? If I do this, then look at this. My x to t, then I can integrate from 0 to t and also from t to 2t, right? I can break that equations to two segments, to two integrals. From 0 to t, my u will be u0. From t to 2t, my u will be equal to u cap t. Right? Because if I do that, I can move my u from integral inside the integral outside the integral. Then I can integrate it. Now, if I do this, then what happens? Then what happens? Then you will find out the first two terms will become EACT, then XT. That's because here. EACT, then XT. My second term will be AC inverse parenthesis AE, the ACT minus 1 BCUT. Agree? Any problem? This is a very simple problem to do. I don't use matches. I use just a scalar. Because a scalar is easy to understand the integral. Now, if I do this, then I can write another integral like this. I say, okay, when time at t equal to kt, my ut will be ukt if my small t larger than kt and smaller than k plus 1t, and k is any integer larger than their integer. If I do this, then I will be able to write this. xkt plus t equal to EA0, EACT x kt plus AC minus 1 and the inverse parenthesis EACT minus 1 and parenthesis BCUKT. Any problem? You can understand about this, because if you understand about this, I can explain to you some physical sense, some physical meaning. This is nothing but a high school calculus, right? This is scalar integrations. But if you look at carefully, real carefully, between this and that, the formulation is identical, except this t has a kt in there, and this t has a kt in there. In front part, this is all the same. This is all the same, this is the same, this is the same, that is the same. Okay? Well, you might, some of you might already taking